one of the exciting scientific findings that we at the Mind Institute have been very involved in is understanding how symptoms appear at the very beginning of the onset of autism. And understanding that is a big part of what motivates me to do what I do. So I want to think a little bit about, if we think that we can use social interventions and interventions that are focused on the social aspects of autism, then we should be able to say why we think that should be important to autism and how it ties into the whole picture. And there's actually been a theory of autism developed by our colleague Peter Mundy and my colleague and friend Jerry Dawson, who think about this issue of social motivation. And they suggest that the biology of autism, the brain level of autism, however that comes about, whether it's through the genetics of autism or exposures or illnesses, that the basic brain part of it decreases children's interest in and pleasure in social interaction. It doesn't eliminate it, but it decreases it. At the same time, it doesn't negatively affect interest in objects or the environment, and that may actually be heightened a little bit. There's an argument going on that no one's resolved yet about whether the balance is just social is down or whether social interest is down and object or non-social interest is up. We don't know that. But anyway, the idea is that early in life, if we have a disorder in which little children, babies, are not very engaged in looking at other people, not very interested, can catch their attention, can enjoy it, but they don't look for it. They don't automatically look around to see what's going on in the room, what's interesting. If somebody makes a noise, they don't automatically look to see what's going on. And they don't imitate very much. They're not attending, they're not so interested, they're not so motivated, they're not imitating very much. They're not tuning into language because they're not tuning into the nonverbal communication that's going on because they're not very attentive. So if you take that away from a little baby, take away imitation and learning how to talk by listening and imitating, not being interested in playing with other people, preferring to be on the periphery of the family, right, instead of the middle of the family. If you would do that to a baby for a few years, what do you think would happen with language development? It's not going to develop very well. Play, it's not going to develop very well. Social skills, there's not much interest. And in terms of what you know about brain plasticity, you know that one of the revelations that's gone on in the last 20 years or so is the change from the idea that our brain structure is fixed by our genes and fixed by the time we're 12, 24 months, something like that, and we just keep packing more into it, to a completely different idea of the brain being a very malleable and responsive organ which builds from what's coming in. And the talents, the networks, the formation of neurons themselves and neuronal connections are the result of stimuli that are coming in and the infant's efforts to make sense of the world. All right, so, and we think that that is very much why language learning period of 0 to 5 years is so much a richer time for language learning than after that. That the flexibility of the brain for learning language and social events, building those networks out, that some of that plasticity really kind of takes hold after a while. And that all that flexibility isn't there anymore. I think about these little plastic brains of babies. But if brain development is dependent on experience and on mastering these skills and making sense of it, then the idea is that we're actually talking about a situation in which many of the brain differences in autism may not have been there as part of the original biology, that they may be a result of having a very, very different experience, one in which your interest and attention are in the object world and not on the language-rich communication social world. And that after a certain point in time, those talents are going to really take hold, just like children who are in athletic families go on to be athletic children. Children who are in musical families tend to go on to be much more musical children, not just because of the genes, because of the whole environment of the family and the culture of the family that's kind of using that infant plasticity and childhood plasticity to develop certain talents and not develop other areas as much. So that's the social motivation theory of autism that fits very well the kind of work that we're doing in early intervention. The efforts to not allow this increasing social deprivation to occur in the early years, to make sure that the inputs for language, play, and social interaction that are coming in are the typical kind of inputs that toddlers need in order to learn these skills. And to prevent this altered course of brain development that is resulting from an altered set of experiences. All right, so in response to and also contributing to this development of this particular theory, I've been working for most of my professional life on developing interventions for young children with autism that are based on developmental science as well as on behavioral science. And the intervention that I have worked on is currently called the Early Start Denver Model. That's the latest iteration of it. This is a published intervention that involves both curriculum tools and a specific content of teaching, and also it involves a set of teaching procedures and practices, interactive procedures and practices that use child interest in materials, children's pacing, rapid changes of interest, very positive, high energy, high affect kind of experience, and very much based on developing the back and forth dyadic relationship, which is the hallmark of all of our relationships throughout our lives. And a few years ago, my colleague Jerry Dawson, who got the funding for the first study of this and was the primary investigator, published in 2010 a paper that demonstrated the results of children who received 15 hours of ESDM in their homes one-on-one for 2 years, compared to children in the Seattle community who received whatever the community interventions were for 2 years of time. Now, the sum total of these hours was not very different. The children who were in the ESDM group averaged about 15 hours a week with a therapist and their parents, who also learned the techniques, worked with them, playing with them daily. That's what work means in ESDM. The children in the community group were averaging 17 hours a week of treatment in various kinds of treatments. So there were not a lot of differences in terms of the intensity of the intervention, but we saw large differences in terms of the effects of interventions on child change. And we found large effects on IQ. The children who were getting ESDM had almost 20-point difference in IQ scores and went from an IQ of about 60 to an IQ of 80 in 2 years of time. That means they're out of the range of intellectual disability, out of the range of severe developmental delay. The same thing happened with expressive language. We see large and significant differences in the language abilities of children who got ESDM, and even in adaptive behavior, which is how parents see their children functioning in everyday life. It's not a test. It's how parents see their child day in and day out across all the environments of that child's life. The children in the ESDM group also showed significantly better development in all those areas than did the comparison group. So that was a very happy finding. That was a happy day when Jerry called me and shared the results. And then a pretty exciting finding that we had in 2012, this paper made a lot of news, was a study that Jerry did, which asked the question about whether the differences that we see in children who've been in early intervention, it's like, are these surface differences? Are these behavior differences? How deeply do the changes go? What does it mean when we see this kind of change in children? So we looked to see whether there were any brain differences that accompanied these kinds of changes. And we compared both the children that we treated and the children who got community intervention with a third group of children, 4-year-olds, completely normally developing 4-year-olds that we recruited for this study. And the children sat in this machine, watching a computer and wearing these EEG monitors, and they just looked at photos that were being flashed across the screen, photos of different people and photos of different toys. And after they'd seen 100 photos, they were done, and we recorded the brain responses to these. And what we found is that in 3 different kinds of measures, I'm just showing you one. Here's the typically developing children show a much more rapid response to faces than they do to objects. And they also show a stronger response to faces than they do to objects. The children in the ESDM group, when the lines are below, that means it's faster to faces than objects. The children in the ESDM group also showed exactly the same response. There were no differences between the ESDM children and the typically developing 4-year-olds on any measure. However, the children in the community group showed the opposite response. They showed faster response and stronger response to objects than to people, and they were demonstrating the same kinds of patterns that Jerry had found on previous studies of children with ASD compared to typically developing children. So this is important because this supports the idea that we really are looking at brain levels of change in early intervention. Of course, we all assume that, right? I mean, where does behavior come from? It comes from our brains. Change behavior. We have to change brain. But a lot of people don't think like that. They think, oh, a little behavior change, a little behavior analysis, ABA, it's just like a Band-Aid. You know, well, fix that habit, but you haven't fixed autism. But it's not just a habit. Brain changes go deeply. And so I think this is the disability associated with autism is very malleable for many children when we find them early enough and can work with them. We don't know which children will be huge responders and which children will be smaller responders. But we do know that for some children, we can prevent disability associated with autism altogether. For some children, like Isabel, we can really reverse symptoms and change problems of eye contact, lack of gesture, lack of emotional expression, and lack of communication. And for virtually every child in our studies, and everybody else's studies too, we can improve the symptoms that are there and improve children's function. So autism in early childhood is very malleable. What about older kids? We've just completed a study of teenagers funded by the Institute for Educational Sciences. We're part of a large project which was working to improve outcomes for high school students with ASD in 4 areas: academic performance, independence and social behavior, social skills and relationships, and transition and family supports. This study was motivated by this quote from Paul Shattuck in 2010. Nearly 80% of young people with ASD after leaving school still live at home. Almost half have no jobs or post-secondary training. 40% never have contact with friends. 17% never feel hopeful about the future. And 21% never engage in outside activities. And many experience a decrease in insurance coverage and therapy services as soon as they leave skills. This is not tolerable, is it? This cannot be how things continue. But it points out that the most disabling aspect of ASD is its effect on social competence. It's social competence that really is the variable that is at play for adults who are doing better and coping better with the demands of adulthood and those who are not. What do we mean by social competence? We mean the ability to understand how other people who are sharing their thoughts and feelings, and to be able to share your own thoughts and feelings effectively with others, both verbally and non-verbally. We mean social cognition, understanding how people work. Kind of everybody's a psychologist, you know. That's because we really understand how people work, what their gestures mean, what their faces say, how they think, how they make assumptions. That's theory of mind, and that is very difficult for people with ASD. How to predict what people will do, feel, think, and say. How to influence them. And finally, social relationships, success in developing many kinds of positive relationships, friendships, groups, romantic relations, and social behavior, managing oneself in ways that help you and don't hurt you socially, is one critical part of this, but it's only one. So we just finished a pilot study in one high school with 8 students with ASD and 20 plus peers, volunteers, who joined the study, and 5 core school staff. We did 3 interventions. One was called peer supports, one was called peer networks, and one was called the social competence intervention. The peer supports were for students with ASD who were getting all of their education in general ed classrooms. And our goal was to increase their participation, by appropriate communication and improved social behavior towards peers in class. The strategies we used were modeling and prompting. This was embedded inside their core academic class with the support of 2 peers from their classroom who volunteered to be supports for them, came to a special group once a week to learn techniques about modeling and prompting, and to work with a facilitator who taught them particular techniques and provided training for them and also for the children with ASD, who are the teens who wanted to come to group as well. The outcomes that we saw, these are just in regular class, nothing special happened. These peers were there, they understood, like it was important to say hi, it was important to wait for hi back. It was fine to make comments. It was good to walk out of class with somebody else and walk through the hall with a partner. It was good to make sure kids were included in conversations that were going on. We found immediate increases in the social exchanges that were going on for the students with ASD in class. We also found the students with ASD increased their social initiations outside of class. We found the staff facilitators felt this was a very positive approach, but the general ed teachers didn't participate as much as we had hoped, and we really have to work more on what to do to support them. The second intervention was called Peer Networks. This was for students with severe disabilities. Our goals again were to increase communication and social contact at school, using the same strategies, using peer volunteers who were with them in a variety of activities and used modeling and prompting to increase and support their initiations. They created some group activities. They created lunch bunch, game clubs, a poster activity for basketball games. They carried out role plays and made videos. And we saw nice increases in the interactions of all the children with ASD, increased participation in a variety of school activities with their non-ASD friends. And the peers really liked this activity. They purported positive outcomes for themselves, their friends, and the teens with ASD, and a decrease in unwanted behaviors. This project was a real exciting project for all of us, and it's worked out very well. And if anyone has is interested in more information, you can contact Amy Board, who's the speech pathologist who managed this project, and she and Aaron Stabel really made this project work.
Having Dr. Rogers go before me was the perfect segue into what we're doing. And a great deal of my work is looking for biomarkers so that we can identify kids at risk as early as possible, so then we can transition them through programs like Dr. Rogers, because that, as she has shown with some amazing data, how effective that can be. So how did an immunologist become interested in autism? And that is a question I got a lot when I first started. I started here back when the Mind was first formed, before this building was built, actually. And it was because the Mind had the vision of bringing investigators in from the outside to address this really complex disorder. And they had listened to parents, and there was more to autism than just they're born that way. And there was this whole biology potentially behind what was going on. And some of the issues that were immune-based. So the immune system is a critical part of normal neurodevelopment. So the immune system is very important. Not the immune system as we think of it as an adult, but the developing immune system and the developing brain, they grow together and they communicate with each other. So this was our view of the brain. This is the blood-brain barrier, which supposedly during the time, and as a matter of fact, when I started working on this, the idea was that nothing gets across that barrier, that the body is here, the brain is here, and they don't communicate with each other. Well, now we know that this is not the case. We have molecules that we call cytokines, so I'm sure many of you have heard about inflammation in autism, or the possibility there's inflammation or the immune system kind of going haywire. Those are the molecules that we're looking at quite often, are those cytokines. They go across the blood-brain barrier from the periphery and talk to the brain, and there are receptors on the neurons that understand what they're saying and react to that. And then antibodies, which I'm going to talk about a lot more, are too big to get across easily. So those we know there has to be something going on that changes the way the blood-brain barrier looks and allows them to cross. Cells go across when you're with certain viruses and certain drug things or certain damage to the brain, then the cells actually move to allow lymphocytes and the immune cells to cross to actually help repair the brain or fight whatever infections there. So there are a lot of things that we now know have changed the way we think about how the brain looks when it's talking to the immune system and that interaction. I know many of you, you know how you feel when you're sick and you have a fever and that sort of that lethargy you get. Those are those cytokines I was talking about, telling the brain, okay, the body, I'm sick, because the brain doesn't know you have the flu until the body tells the brain you have the flu. And it's that communication coming from the body to tell the brain, you need to take a nap now. You need to sleep. You have a fever. It's time to slow down. So I think it's that kind of communication that we didn't really appreciate until recently. And that's really helped us quite a bit to figure out what are the things that we need to look for that is going on in autism. So that is a lot, that's sort of a global picture of what we're doing in the immune system, and much of that is in the children today. And I'm going to talk about one specific area because I'm not going to stand up here for an hour. And one of the things that we're talking about are autoantibodies. And autoantibodies, you know, you make antibodies to, when you get a vaccination, those antibodies are made to fight whatever you're exposed to because they block it. They act like a sponge. They bind to it, block it, and remove it. And that's what an antibody's job is. However, sometimes the body mistakes their self-tissues for a foreign tissue, and they make what we call autoantibodies, auto meaning self. And those antibodies react, they don't distinguish that your proteins in your body are yours, and they start attacking it as if it were foreign. So we did some work both in children, and we've done quite a bit of work in mothers, in the women, because we're looking at the gestational period or during pregnancy, what's going on. And this is just a very brief slide of some work that I did with David Amaral, my student Sharifa Wills did, where we identified antibodies in children, so these children are between 2 and 5 years of age, that react to these cells, which are Golgi cells, and this is in the cerebellum. So this is a Purkinje cell over here, over here. And we found this very strong reactivity in some children, not a huge group, but these children, those children who have these antibodies had lower function. So when Dr. Rogers was showing the scores for the Violin and the Mullins, they had lower scores, even if they were typically developing children, so even if they weren't autism. So what we found is these antibodies aren't a marker for autism, they're a marker for potentially something going wrong, something happening or changing the way the child learns and their function, their daily function. So we're looking at what's going on with those, and we're still examining, you know, what those are recognizing. More work has been done on we've worked sort of really concentrated our work of trying to identify kids even before conception. So mothers who are at risk of having a child with autism. And I'm sure as many of you know, having a child with autism increases your risk of having a second child with autism. And now I think it was at 17 to 20% increased risk. So we're really interested in what is conferring that risk, what is causing that risk besides genetics. And so we have found antibodies that are autoantibodies that mothers have that recognize brain proteins in the developing fetal brain. So this is our working model. It all began with this, you can see this tiny little picture up here. It was one of those moments in the lab where you go, you know, we should look at this, and immunologists think everything is caused by immunology. So I had worked in autoantibodies before I started working in autism. So we just screened some blood from mothers to see if they had anything there. And what we found was in some mothers, a percentage of mother, they had this pattern. This is fetal brain that we ran, and we separate the proteins out, and we put the mother's serum on that blot, and we saw this band pattern. So these mothers are making antibodies, and we have no idea why. We have no idea what causes it. Making antibodies that recognize these proteins in fetal brain. Now, during pregnancy, the adult blood-brain barrier is blocking these. Remember, I showed you they're too big to go in the adult, so we don't think that they have an effect there. But during pregnancy, the mother makes antibodies. Everything that she's seen, everything she's been exposed to, she's protecting her fetus from all of those things. So everything that it's normal, IgG crosses the placenta and protects the fetus because the fetus doesn't have a functional immune system at this point. So it's very important for the health of the fetus. Unfortunately, and because the developing brain is, the blood-brain barrier is more permissive and allows these antibodies to cross, anything that the antibodies recognize that are in the fetal tissue, they will react to those as well. And there are many cases of other autoimmune disorders where it has an effect on the developing child. So we think that these antibodies are interfering with brain development, which increases the risk for autism. So this is what we're now calling this maternal antibody-related autism, and that's sort of our working title at the moment for this. There's a lot of science that we have had behind this. And remember, Dr. Rogers said, you know, one study is good, gives you hope, and that's what that first study was. But there are many, many studies that need to be done to validate these findings, not just by you, but you hope that someone else validates them somewhere else, because that's really important in science. So this began with our large population study and that Western blot, and we found that children with these who have come from mothers who have these antibodies had worse language, greater language deficits, and increased stereotypic or repetitive behaviors. These kids, if we put them on the severity scale, they're at the more severe end of that scale. So these are not the high-functioning, very verbal, you know, kids that mainstream. These are the lower functioning kids that we're seeing these antibodies. We've looked at the genetics, and we found there's a gene, and I won't go into this in depth, but that was found by a colleague of mine, Pat Levitt and Dan Campbell, that there is a gene that confers what we call susceptibility, meaning if they have that gene, they're more likely to make the antibodies because of what that gene controls in the immune system. When we looked at imaging of brains of these kids, we found that children, especially boys, who come from mothers with these antibodies have larger brains than even the larger brains that we see, the greater growth trajectory, I should say, of children of autism versus typically developing children. So they are above even and I'll show you, I think I have that slide in here. The basic science part, for me, the most critical piece was, what are these antibodies recognizing? And this is the work that this took us a long time, actually. On paper, sometimes science is very quick. In reality, it can be very frustrating and slow. But we now know what these antibodies recognize, and that helps us, because by knowing that, now we know what system might be impacted, when it's impacted, and potentially something that we can do something about it. We have now 2 monkey models and 2 mouse models that if we take antibodies from a woman who has them and put them into a mouse or a monkey that is pregnant and look at the behavior of the offspring, we see autism-like behaviors in the offspring. So I think that shows us that these antibodies are potentially doing something. The other interesting piece of this is Melissa Bauman just published a paper this last summer that a monkey model, they also have larger brains, so that the male monkeys that were exposed to these antibodies look just like the male ASD humans, that they have their larger brains than their peers. And then we're looking at the brain tissue to see what's going on in that tissue. So we hope that this has translational potential, and by that we mean that we can take this research finding and work on it and develop it into something that can go back out and to help the community, that we can, through this research, can we identify kids with this phenotype? Could we put them through the Early Start Denver model, and would they be the kids that might actually benefit from that? Because we can pick them up very early. So those kids could benefit from that very early detection. Screening women at risk and helping them understand what their risk level is for having a second child with autism if they already have one on the spectrum. And if we can find sort of what the pathology, by that I mean what changes are happening in the brain, could we come up with some kind of therapeutic, sort of small molecule therapeutic, a drug therapeutic, that could fix that pathway that is altered. And this is our brain. These are what the proteins are. We have 7 proteins that we have found, and each of them is important for a different part of neuron development. And when you have a combination of antibodies, meaning you react to more than one of these, it builds, and the more you have, the more severe your outcome. So you can maybe affect sort of a part of a system with one of them, but when you start stacking them on with each other, you end up severely impacting brain development. Now, the important thing to remember is a lot more neurons are developing than we have antibody at any given time. So you're not wiping out the entire brain with this. You're just changing the trajectory of development. You're changing the way the brain is developing. So this is what our percentages are. So we have about 23% of mothers who have children with autism fall into this category, have this, I don't know if it's a type of autism, but it's certainly a subcategory. I think it's a subphenotype. It's very specific. The only child that we had whose mother was positive was very high on the aberrant behavior checklist for hyperactivity. So we think that maybe one of these patterns might actually relate to hyperactivity, which is, sort of in line with the stereotypic behavior in the ASD kids. So this work is ongoing. We're still looking to see if this actually would be a good screening tool. And this, I'm just going to go through quickly. This is for the MRI that we did. This is what it looked like. So the middle bar there those are the children whose mothers had these antibodies, and you can see they're significantly higher than even the ASD population. So we have a lot of studies in the lab going on where we're looking at both the children and their mothers to understand the evidence of how the immune system plays a role in development and how having changes in immune function impacts that development. We're looking at the genes, we're looking at inflammation. Does inflammation play a role in some kids? And immune function is altered. We're looking at immune function in children with autism, and we see kids with very high activity, almost sort of what we would term as inflammation. We see kids with very low. Some kids who have nothing. I mean, when I stimulate their cells, they practically do nothing. They're almost immune deficient. And then we see kids who are perfectly normal, in line with the typically developing population. So I think it's really important when we're doing this work that we need to be mindful of that big range of differences, especially in the biology, which makes it a little more difficult. And as I talked about, we have evidence of autoimmunity, autoantibodies in both the mothers and the children. And as we go forward, we hope that these provide both meaningful information and a pathway to therapeutic. And then immune dysfunction could be associated with impaired behavioral outcomes. We think they are based on the animal models. We think they are based on the relative behaviors that we see in the children who come from these mothers. And definitely we think there's a change in physiology based on their total brain volume. So this is where we are now. We know what the targets are. We now know what part of the protein, that's what the little black box is there. We're now actually figuring out exactly what part of the protein these antibodies are recognizing, and we've got that done. So now, instead of passively transferring human antibodies in, we will use an animal model where we will break tolerance to the protein in the animal, breed the animal, and look for behavior in the offspring. So then we will expand that back into the monkey model, because I think this is where we're going to need to be. The monkeys have much more refined social interaction, and we're going to need that level of social interaction because autism it's a sophisticated disorder. It is something, there's a lot of nuance to it. So I think the primates are going to help us out a little bit more. We hope to, in the future, that this will be a biomarker for early risk, for understanding early risk in this high-risk population. And hopefully we will end up with eventually a therapeutic that we can, that's a long way down the road, and I can say that right now, and it could be 10 years from now that we finally get something successful. But I think we're hopeful, and that's where the animal models will help us. So this is my team. I don't do this work in the lab. I write to get the money to do the studies, I think, and then with the poor staff are the ones who are out there slogging away at it. But I have a great team who helps me with all this.
We're going to have a major gear switch here because I'm not talking about neurobiology. I'm talking about road to employment, as you can see, especially from a maternal kind of perspective here. So if you meet Temple Grandin, she will have two questions for you. One is, what is your name? And one is, what did you do? What do you do? If you answer you don't do anything, she'll want to know why not. So our children are kind of ridiculously underemployed right now, especially with the economy and the recession. Competitiveness is fierce. And for us living in a college town in Davis, competition for what part-time jobs there were taken up by college students. So for Fallon to become employed was a pretty long, arduous journey, and it all began with Workability. Has anyone here ever heard of Workability? Okay, a few. It's a state of California program that we were introduced to when Fallon was in the 9th grade. In Davis, high school is 10th, 11th, and 12th grade. So for his 9th grade transitional IEP, we were first aware of this term. And what it is it's a wonderful program where it's written into the IEP that they have job goals. The jobs typically relate to the child's interest. They're paid through the state of California, not through the employer. So for Fallon, his interests were writing and gourmet foods. And for writing, we thought the library would be a nice fit for him. It's pretty quiet. And he was placed at the Davis Library. Another possibility for children when they're in high school is just to volunteer. And Workability works really great with volunteering because it only functions during the school year. Fallon was able to then turn his Workability opportunity into a volunteer internship over the summer. So he did that for 2 summers in a row. It really helped him to form connections in our community, to gain some really important knowledge about job skills, working with other people, following directions, staying on task, asking for help when it was needed. Nonprofits are a great place to look for volunteer opportunities. Friends and family can also help. It can be kind of overwhelming and difficult when all of this responsibility is strictly placed on the parents. School only helps during the school year. So if you can have some outside kind of support, it really is great. So the other thing we did for Fallon once he graduated high school, which we were really thrilled about, was we took him to a career advisor. I would really recommend this. They conducted a personality assessment on him, like your standard Myers-Briggs. That way you're not really kind of guessing in the dark or struggling just on their interests, but you can go for their temperament or personality type, and those usually come with a complete list of potential careers that might interest your youth. They worked with him on his resume, and because he had participated in Workability and been a successful volunteer, he had letters of reference. He actually had content to put on a resume. This is really important for the competitive nature of job hunting right now. So they also walked him through some online tutorials. And the majority of jobs nowadays you really do apply online. That's kind of a mixed blessing. I mean, on one side, you're kind of a face in a sea of money, but on the other side, handwriting isn't a problem. So then at home, this was kind of the final component for us. We did a lot of role playing, sitting down with Fallon and practicing interviews, sharing personal stories with him on what we remember, what questions we were asked, what was successful for us, what was scary, what was hard. Family support for the youth is really important. Help them come up with some clear set goals. We started probably when he was born that it was expected he would have a job as soon as possible. And of course also go to college. So strengths versus weaknesses, like I said, Fallon loves gourmet food. So when it came time for his first paid position post-high school, the natural fit for him was Nugget Markets. It's a beautiful store in Davis. We've always shopped there. He was very acclimated to it because he'd visited so many times over the years. So his writing skills came into play. He wrote a beautiful cover letter, hand-delivered it in person, which was one of the few opportunities that he had to do so, dressed impeccably, taught how to shake a great hand. And lo and behold, after 2 interviews, he got the position. So Fallon's been employed at Nugget Market for just over a year now. It's been very successful. We still have some challenges learning how to handle money. But I would love to let Fallon kind of share with you his experiences.
Now, I will just be essentially picking off where my mother left off. Upon my interview at Nugget Markets, I disclosed that I had Asperger syndrome, which was met with rather interesting. Sorry. So, disclosing Asperger syndrome. That's where I left off. Disclosing Asperger syndrome. I dressed impeccably. The interview was going excellent. I decided that I would say, hey, I have Asperger syndrome. Here's what it is. Here is how it relates to my strengths and weaknesses, so on, so on and so forth. It is a part of who I am. Naturally, this speech impediment was kind of a giveaway. So that added a lot of leeway. But they actually took it remarkably well. They just were like, hey, he works hard, he seems sane, let's hire him. So therefore, that was my first step into the community that was Nugget. Now, there are many things I love, many things I don't love about my job. Now, this is perhaps the most unexpected thing that you could anticipate a person with ASD to enjoy about their job: the water cooler. Now, I have numerous friends at my employers. First and foremost, a 40-year-old gamer named Larry, brilliant guy, humorous, witty. Regardless, he and many of my other colleagues, it's no real secret that I'm on the spectrum. I'm open about it. Here's what I do, and here's just an idea of how I work. I have not had a single person think less of me because of that. If anything, they think better and better of me because I'm so open and borderline flamboyant about it. Of course, this also has, being part of the janitorial staff and having to love gourmet food and classical dystopian literature. This does not click quite as well with my initial profession there. Time management. A lot of you parents with children on the autism spectrum, you know no doubt and don't know how immensely difficult it is to get your kid to just prioritize time well. I myself am no exception, and I am 20. Time management. Regardless, there are many clocks scattered throughout the store and our adjacent warehouse. Naturally, when you are as obsessive and object-oriented as I am, it is very easy to lose track of time. You're sitting there and polishing something, and oh look, I spent 20 minutes on this one surface. I still have to sweep the entire store. Yes, that has happened on more than one occasion, but hey, I'm still employed. Of course, there's also asking for help help, which is of course an issue. But eventually I came to the epiphany long ago that honestly, I'm getting paid to do this. If I'm not sure on what I'm doing, I should probably ask. And that worked wonders. Those of you who I take you, and you all are, have some knowledge on level A and ASD, specifically level 1. Level 1 aka Asperger Syndrome, as it is colloquially known. You would know that passion is immensely important to any individual with Asperger Syndrome. As a person with this, as I've repeated, these are fundamental to who we are as human beings. Without these cornerstones, be it trains, video games, music, food, we would be lost without this sort of anchor in this implacable world of indescribable and frankly arcane world of neurotypicals. And it's just to have these passions, if anything, they can help us relate to others and utilized properly, they can get you places with this tenacity alone. This is where the fun part is. At Nugget Markets, there was a cheesemonger opening. You can tell where this is going. I nearly wet myself with joy. Approached my manager. I was like, "Hey, I hear you have a cheese opening. Yeah, I'm really into that. You know, I'll also submit a cover letter. Okay, cool, awesome. Next thing I know, the interview happened. Positive feedback. 2 weeks later, Fallon, there was only one position available. That said, because of your passion, keyword there, passion, they use that. Because of that, we actually considered opening a second entry level cheesemonger position. Man, you got it. And so I start training next week. And so, like I said, with people on the autism spectrum, just utilize your passions. It's just, they are tools. They are tools to make you successful. If there's any sort of compensation you have for social shortcomings, it's your extreme specialism in subjects of interest. Take advantage of that. I have, and hey, I'm a cheesemonger. And with that, that's really all I really have to say. I mean, comedic banter and heartwarming story of Asperger's. So.
Here's a quick one. Dr. Rogers, is there a plan to put the role-playing project at one of the Sacramento adult disabled schools? No, we don't have any plan to do that. I would love to be working in the Sacramento schools. And if anybody has an in that would help us be invited into that, please have somebody call me. Anybody can call me at any time. But it would be great to be working in our own school district. I agree. Do you want me to do more than one?
Do 2, and then I'll have Judy
Okay.
with hers, and then I have.
Okay, this is an interesting question. Okay, were you able to, quote, normalize the degree of ASD in the study group? You know, that is a really interesting question, because all of the early intervention people who are working on these projects, what is the most flexible are these developmental outcomes of IQ and language function. And in terms of what predicts outcomes in people with ASD, it's not the severity of their symptoms. It's IQ, school performance, and language function. So it's very interesting. I think for a long time people thought, well, changing the symptom patterns was the holy grail. But it is, I'm not sure it is. And I think the way I think about this is about the difference between autism characteristics and disability caused by the disorder. And my goal in life is not to erase autism characteristics from children or people that I work with. It is to remove disability from their lives. I want people to experience life as satisfying in every aspect, socially, productively, recreationally. For me, that is what life is all about. And whether you are somebody who has talents and interests like Fallon does, I mean, that's a gift. That's joy. That's a part of his personality that he really enjoys. Who would want to change? Why would you want to change that? We all have other things we're interested in. And I've heard many, I used to do adult social skills groups, and an adult said to me once, it's not the autism that's my problem. I like my mind. I like who we are. I just wish life wasn't so hard with autism. And I think that's quite a profound statement, and it also goes with the idea that you, I'm sure, are all aware of, is that there is no line in which this side is ASD and the rest of this side is non-ASD. It doesn't work like that. And anybody who says the score on this test is the difference, that's not the truth. The truth is there's this gradation of ability, social ability, from people who are ultra-social and ultra-related to people who are kind of typically related, to people who are less into social relations, intimate conversation, spending a lot of time with people. We're not talking about anybody with a disability. We're talking about individual difference here. And there's a point at which that individual difference ends up causing people difficulties in basic life function. That is disability. So kind of getting back to the idea, what's the difference between autism symptoms or characteristics and ASD? ASD is a disordered, it's disordered function in everyday life because of your symptoms. My goal is to have people functioning well, to help people function well, and to have their symptoms be characteristics, personality styles, which are a very successful way of coping for many people and enjoyable. So to me, I think that it's very important to think about ASD as this dimension, this continuum, and not this line. And I'm not trying to get kids over a line. I'm trying to help them function and help adults function in the three main areas of life. Like Freud said, love, work, and play. What makes a healthy life? Love, work, and play. And I think that is a very important thing to hang on to when we're talking about people with developmental disorders of any kind.
You did too. Okay, you just rolled it all into one big one. Okay. So my question is, many doctors don't recognize or have knowledge about the mind-body connection and autism. What should a parent with an autistic child do? And what are your thoughts on Dan doctors? Well, that's a really loaded question. Thank you, whoever wrote that to me. So, you're right. I think we're changing the way the medical community thinks about the whole body, the mind body. And I think the two comorbidities that go along with autism, I think that most impact are the GI symptoms and seizure disorder that children have. I mean, those two things, we need to address those. And I have colleagues at Mass General who, in addressing the GI issues in, even these are young adults, these are not just little kids, these are, sort of teenage age, gets rid of the sort of self-injurious behavior and the stereotypic behavior, because they have no way of expressing that they have those issues. They have no way of telling their parents, and their behaviors are not reflective of where the issue is. And I think, I hopefully we're trying to work toward a better understanding of that, and that physicians are treating the whole child, not just their autism. I have parents who tell me that I went to the pediatrician and they said, oh, for something unrelated to the autism behavior, oh, but your child has autism. Well, yeah, but my child also has this. So I think that is the frustration that parents have had up to this point. And I think, and it's difficult. What should a parent do? Hopefully work within the community to find somebody who does understand sort of the whole body of the child, not just their behavior. My thoughts on Dan, well, the Dan community actually doesn't exist as the Dan community anymore. They've changed sort of there still are individuals within that sort of I don't want to call it alternative, but I think more interested in the medical, the biologic versus just the behavior. And sort of getting the child healthy, and I think we're thinking here, we just received a grant for the IDDRC, the Intellectual Disability Corpus grant, and one of our projects within that is to understand how, if making the children feel better, getting their biology sort of back on track, will help them with the behavior intervention. They'll be able to attend to it better, they'll be more receptive to it, and I think that's sort of the idea of the Dan community, such as it, whatever anybody thinks about it. It's not a bad idea that if your children are healthy physiologically, they can be more attentive to any kind of intervention and sort of therapeutic regimen that they might be going through. So I guess hopefully that answered the question.
The UC Davis Mind Institute was created in 1998 with a promise to find cures for neurodevelopmental disorders. Every day, our physicians and researchers come closer to fulfilling that promise. Their groundbreaking research on autism, Fragile X syndrome, chromosome 22q11.2 deletion syndrome, ADHD, and other brain disorders are helping children achieve their fullest potential. Please visit our website to find out more about current studies, upcoming events, and how you can help make a difference.